What's going on, guys? So in this lesson I'm going to be walking you through a 6-marker question all about ideal gases. First of all, before you obviously tackle this question, make sure you understand the difference between the following formulas. PV is equal to nRT, and although we're not going to use it in this lesson, PV is equal to nKT. If you don't know what these formulas are, look at in the description. I'll put my video link in the video which explains both of them. PV is equal to nRT and PV is equal to capital NKT. Lowercase n is the number of moles, capital N means the number of atoms or number of molecules here. Okay, let's read out the question. So obviously pause the video, maybe try it yourself, and then obviously unpause it and then watch me walk you through the problem. The laws of football require the ball to have a circumference between 680 millimeters and 700 millimeters. The pressure of the ball in the air is required to be between 0.6 times by 10 to the power 5 Pascal and 1.1 times by 10 to the power 5 Pascal above atmospheric pressure. A ball is inflated when the atmospheric pressure is 1 times by 10 to the power 5 Pascal and the temperature is 17 degrees Celsius. When inflated, the mass of the air inside the ball is 11.4 grams and the circumference of the ball is 690 millimeters. Assuming that the air behaves like an ideal gas and that the thickness of the material used for the ball is negligible, deduce if the inflated ball satisfies the law of football about the pressure. Okay, about the pressure. So the question is asking you to check that is the pressure of this ball within this range that they've told us that it should be. It's a nice context as well because, like, before football matches, someone actually has to check the pressure inside the ball and see if it fits the criteria. So let's try and see how we're going to work out that pressure. So let's look at this formula over here. So we know that PV is equal to nRT. Yes? Okay, so therefore P is equal to nRT divided by V over here. Okay, but we don't have the number of moles. We don't have it. They haven't given it to us directly, but we've got this. We've got the molar mass of air. So this tells you the mass of 1 mole of air. So this is the mass of 1 mole of air. Okay, right, so this is the mass of 1 mole of air. So if you want to work out the number of moles, you know the total mass and you know the mass of 1 mole of air, you can simply do the following. Well, you can do the number of moles is equal to the total mass divided by the mass per mole. Yes, mass per mole. Because obviously, you take the total mass divided by the mass of 1 mole, that will tell you how many moles that you've got. So this becomes at the top 11.4 grams divided by 29 grams per mole. Make sure you recognize that. It's because this is going to be, and now look, you can see it cancels out. Grams divided by grams, 1 over mole minus 1 becomes the number of moles. So this therefore tells us the number of moles over here, which is going to be equal to 11.4 divided by 29. It's going to be equal to 0.393 moles. That's how many moles you've got of the air inside there. So although they've given you the mass of the in total, because they've also given you the mass per mole, you can actually work out the number of moles. So that's a bit of a trick, yes? Make sure you can recognize how to use that formula. Let's put it into here. 0.393 times by the molar gas constant, R, which is 8.31, they'll give you that in the exam, times by the temperature. Right, the temperature is 17 degrees Celsius, but don't forget this formula only works if they are going to be in Kelvin. So we need to convert this into Kelvin. So 17 degrees Celsius, to convert to Kelvin, you simply add 273. So 17 plus 273. So my value is going to be 17 plus 273. It's going to be 290. 290 Kelvin. That goes into here. So 290 Kelvin divided by the volume. Okay, but we don't have the volume. We actually don't have the volume. That's a bit ugly. Let me just try and do that again. Too far. Oh, there we go. I just don't want to make that line ugly there. Divided by the volume, but we don't have the volume. The volume of the ball is like a sphere. So obviously the volume is going to be equal to 4 over 3 pi r cubed. Okay, but you don't have r. Look carefully, you actually don't have r. But they've given you the circumference, 690 millimeters. What is the link between the circumference and the radius? Well, hopefully you recognize that. Pi d is going to be the circumference, but don't forget d is equal to 2r. So it's going to be 2 pi r is equal to the circumference here. So therefore, rearranging it, r is equal to c divided by 2 pi. Therefore, it's equal to the circumference 690 times by 10 to the minus 3 divided by 2 pi over here. We can work out the radius. It's going to be 690 times 10 to the minus 3 divided by 2 divided by pi. So I'm getting the value of the radius to be 0.11 meters. That's my radius. Now finally I can actually use that to work out the volume. I'm just going to change the color of the pen so kids don't get confused. So 4 over 3 pi open bracket r 0.11 cubed over here. So it's going to be equal to 4 divided by 3 times by pi times by 0.11 close bracket to the power of 3 over here. I'm getting 5.6, let's just round it over here, times by 10 to the minus 3 meters cubed. Excellent. So then finally we've now got the volume. Let's chuck it into the pressure. This one over here, so 0.393 moles times by 8.31 times by 290 divided by the volume that you've got, which we just worked out, 5.6 times by 10 to the minus 3. Voila les enfants. So it's going to be 0.393 times by 8.31 times by 290. 290 divided by 5.6 times 10 to the minus 3. Over here, I'm getting the value of 169,123. And then in standard form, that's 1.6, 1, 2, 3, 4, 5 times by 10 to the power of 5. So the pressure is equal to this. I'm just going to just put a line so that we don't get confused about which bit we're looking at. There we go. So the pressure is equal to 1.6 times by 10 to the power of 5 Pascal. Okay, right, so now, finally, don't forget we've got to deduce if the inflated ball fits this condition. Is that true? Does it fit the condition they stated at the start? There we go, over here. Well, does it? No, clearly not, because it's higher than that value there. So, no, the ball does not satisfy, as the 1.6 times by 10 to the power 5 is greater than 1.1 times by 10 to the power 5 Pascal. There we go. Right, so this was quite a tricky question. Loads of bits to get your head around. My advice is obviously make sure you understand this formula. We didn't need this one for this question, but it's nice for us to be aware of. Making sure that you recognize how to calculate the number of moles. Yes, by total mass divided by the mass per mole. Recognizing converting the 17 degrees Celsius into Kelvin. That's another little bit over there. The circumference is equal to 2 pi r. And then using the value of the radius here and chucking it into the volume over here and combining them all together. And finally, the conclusion of 1.6 times by 10 to the power 5 is greater than the range here. So this is a 6 marker, and I know it says 11 marks at the bottom, but that was because there was 2 easy questions at the start. But I wanted to look at this calculation because it's in the calculations which loads of kids get stuck. And obviously, guys, if you're still struggling, check out my YouTube channel. I've got loads and loads of content to help you. Comment below if you think I've done something wrong or you need more support, and I'll be able to help you. And yeah, and let me know your thoughts, if any. Take care, ciao, ciao, and good luck in your studies. All right, I'm going to stop the live stream. Whoops, where is the mouse? I can't do it. There it is. Okay, so 3, 2, 1, good luck.